Hello everyone, I am Dr. Kumar and today we are going to discuss about a cathode ray oscilloscope. This is indeed a very short video and we will be discussing here mainly the cathode ray tube. So cathode ray oscilloscope is an versatile instrument to visually observe wave shape or the waveform and to take the different measurement from that waveform. The cathode ray oscilloscope can be used for both DC and AC current, and it can measure current and voltage. It can measure the wavelength and frequency, phase difference, and by cathode ray oscilloscope you can perform FFT, that is fast Fourier transform. And then you can measure pulse width by CRO along with rise time and fall time. Now the main component of cathode ray oscilloscope or CRO is the cathode ray tube. So this is the schematic diagram of a cathode ray tube. So it consists basically a highly evacuated funnel shaped glass tube. The electrons are emitted from the cathode and transformed into high velocity electron beam by a number of electrodes. The electron beam moves through the evacuated space of the tube and strikes the fluorescent screen. Thus, the spot of the light is produced at the place on the screen where the electron strikes it. Now, the whole cathode ray tube can be divided into three parts. For example, electron gun, deflecting systems, and fluorescent screen. So, we'll be discussing one by one. So, let's first talk about the electron gun. So, the electron gun basically consists of a heated cathode, a control grid, an accelerating anode, a focusing anode, and a final accelerating anode. Now the electrons are emitted from the cathode and the control grid is kept at a negative voltage with respect to the cathode. So this voltage controls the density of the electrons in the beam. Now by making the control grid potential more negative, the beam current is reduced and so the brightness of the spot. Therefore the grid bias controls the brightness or intensity of this beam. Now the accelerating electrode is kept at a high positive voltage with respect to the cathode. This electrode therefore speeds up the electrons passing through it, and the combined effect of the focusing anode and the final accelerating anode focuses the electron beam into a tiny spot on the screen. Now the anode system is termed as electron beam system since its action is similar to the optical lens concentrating a beam of light. The second part of this cathode ray tube is the deflecting system. So in most of the cathode ray tube there are two sets of deflecting systems. One is known as the vertical deflecting plates and another what is the horizon deflecting plates. And this system deflects the electron beam and sweeps the spot on the screen according to the voltage applied to the horizontal and vertical deflecting plates. So a moderate potential difference is applied in the two plates of the deflecting systems. So one plate is at a positive potential whereas the other is at a negative potential, and since we know that electrons are negatively charged particles, so the electron beam will attract towards the positive potential of the plate, and by changing the potential difference between these two plates we can change the directions of the beam. And now the third part of the cathode ray tube is the fluorescent screen. Now the inner part of this fluorescent screen is coated with a fluorescent material also called the phosphor. The purpose of the phosphor is to produce a spot of visible light at the place where the electron beam hits the screen. The color of the visible light is determined by the phosphor. For a general purpose, a yellow-green light is produced since for this light the sensitivity of human eye is very high. So this is the basic structure of this cathode ray tube.